Hello and welcome. In this video, I am going to present an introductory lecture on NS3. So stay tuned. If you're a beginner in NS3, this should help you get started with NS3. Sorry, my lights are flickering because, I don't know, the power company have a problem with it. Anyways, so this is an introduction to NS3. Let's start. First, let's assume that you have it installed already. But before we get into it, what is NS3? It's an open source network simulator written in the language of C++. So it's code written in C++. So you need to compile C++ code. You need to know C++ coding. And you can simulate complex and simple networking scenarios. And you can also write scripts in Python, although it is not recommended because there's not a lot of support for Python. The requirement. So if you want to install NS3, go to this website and click on it, and it should take you to where you need to be. So this is how you install it. You need to at least install G++, which is the C++ GCC compiler, and Python 3 because Python 2 reached end of life. Python 2 is officially obsolete. I mean, maybe there is a little bit of support, but everyone is migrating away from Python 2. And basically, you need Python 3 because the code is being run by a tool written in Python. Okay, but I digress. Maybe I do this. I'm back to my, so this is the installation instruction. You may need to install other packages as well. So I suggest you install Python. So this is for NS 3.28 and earlier. So if you're using a newer one, skip this line. For Python 8, Ubuntu 18 and NS 3.29 and later, we will install these components. I'm interested in PyGraph Viz, Cairo, which is, I think, is a user interface or animation. But you need this if you want the PyViz visualizer, which I actually use sometimes. The rest, I don't think you need this. If you are using the Bake tool, you'll install these tools. Anyway, also install GDB if you think you might need to run the simulation in a debugger. All right, you can also use Clang++, which is Clang implementation of C++, and you can actually configure it to use that compiler. To get the most recent code, or you just clone this link, be aware that older NS3 versions used a different website. So everything is now in the GitLab instead of a different website that they used in older tutorials. You can change into Bake directory and then run the Bake tool. Of course, you might need to install some Python packages that they use. So install pip, which is the package installer for Python. It's the preferred package installer or the de facto. It's like the apt-get, but it installs Python libraries. And there's a lot of Python libraries. You want to get familiar with pip, and you want to learn Python for your own good when you play a lot with Unix and running scripts and automation and stuff like that. Anyway, but I'll assume that you have this already. So if you have it running, Bake configure, this is the latest version, 3.331 as the time of making this video. Download and then build. And then basically go to the directory 3.31 and then do make configure, which actually runs this command, configure enable examples, enable tests, WAF build, and basically you build it. Once the build is done, run WAF -- run examples /tutorial/first. Let me get into this directory and show you where this is. Examples, tutorials, and it is this first.cc, but there's also something called wscript file, which is actually written in Python but without an extension. If I examine this file, wscript, you can see here that the source code is first.cc, but the program is registered as an NS3 program named first, so without the .cc. If at any time you run something that does not exist, so let me clear this, waf -- run something that doesn't exist, it will tell you hold your horses. I will show you all the list of programs that you can run from NS3. As you can see, this is source.aodv example, different kind of NS3 programs that you can run. Anyway, let's go back to my, that's too small now. Okay, let me go back to my lecture slides. Okay, so everything needs to be run from the NS3 root directory. So the root directory is this one here. It has a examples, contrib, binding, build, doc, scratch, and scratch is where you put the code that you write, utils, and this is the WAF tool. So we always run it like this, WAF -- run, okay? Let me also look at the make file. When I did make configure, I basically configure it by disabling warning errors and enabling examples. Let me do make configure to show you what my make configure does. It says that I'm using G++, that's the compiler, that's the version of the compiler, and some other things, the Python executable, the Python version. And if you go down all the way here, I have PyVis enabled, which is the visualizer if you want that running, and the Python binding. If you need help with that, send me an email and I can help you fix your problems. Anyway, this is my present working directory. It's NS3.30.1. So that's the version I'm working with. I actually did upgrade it to 3.31, but I did not change the name of the directory. But anyway, so what am I going to do? Let's go back to the simulation, the slides, sorry. So you can configure it with Clang++ by doing Clang++ like that, WAF configure. And anyway, and that's if you want to configure a different compiler. You should choose an IDE to edit your code. You can use Vim or whatever you want. I recommend Visual Studio Code because it's available on Windows, Mac, and Ubuntu. You can also use Eclipse, which is also available on all. So for that, you open the code and then basically point it to the build directory so that it activates the auto completion and all that good stuff. I have a video specifically on that, so I'm just going to skip over these. You can also use Eclipse CDT, was it C Development Toolkit? I think that's CDT. And the same thing, you could configure it with syntax highlighting and whatever you want. So this is the NS3 directory structure. You have the source. Oh, where did we go? SRC, examples, contrib, build, scratch. Those are folders that I'm highlighting here. And the source basically is where the NS3 module code is. So don't play with this one. Examples is where they store some examples. So don't play with this one. Don't play with that. Contrib if you want to create your own libraries. So you probably don't want to create your own libraries yet. Build is where newly created, basically whenever you build code, the executables and the header files are copied there. Scratch is where you play. So Scratch is where you have your code, your examples, your projects. And in most directories, there is a file named wscript. There is a wscript inside source. There is a wscript inside every folder inside source. And then within every folder inside source, there is a folder named examples, and it has a W script. Now, let me just show you this quick. CD source. There you go. There's a W script. Let's open network. There you go. There's a W script. And inside examples, there you go, W script. And if I look at this one, W script, it has main, it creates, basically it points to the header files and it names the program. So I can actually run this as a program by doing waf -- run. And okay, I have a, let me clear and let me header. So it runs that code, or you can also do it like this: source network examples main packet header without the CC. Same thing runs. I'm not sure if it generates any file. No, it does not generate any file. You don't do .cc in this case because that's how they registered it. Anyway, so moving forward, this is why they're registered like that. You can run some examples from the examples directory. For example, here UDB echo, which is one example, which is in this file, udb-echo.cc. Whenever you run WAF to run a program, all code that is under Scratch will have to be compiled, so there should be no errors. And if you didn't disable warning error, then if there is warnings, it will stop on warnings. Anyway, so this example, if we run it, UDB echo, I think I can run it like this: UDB echo. Didn't output anything, but there is actually files that were created that you can open with Wireshark. I think I could do Wireshark, paste. So as you can see, there's a packet capture file. There are ARP, address resolution protocol, that's to resolve the MAC address with the IP, and then UDP packet, and then the reply. So this is from 111 to 112, and then 112 is responding to 10.111. Okay? And for every, I think this is basically, this is the device, the node ID. So basically it's numbered like that. Anyway, there's also a trace, UDB echo.tr, which is an ASCII code of the example. Anyway, let me remove -f, UDB echo. Let me just remove all these directories. So all files created relative to this path. So if you can create a directory, my output, so you can point to it from your programs like that. Anyway, going back to my lecture slides. So yeah, you could examine these PCAP or the trace files in ASCII. If you need to pass arguments, then you write the program name, quotation, right? So if you create a directory under Scratch called project1, and you can put multiple files, C++ files, but one of them has to have the main function. So let me go here and show you that. So under my Scratch directory, I have multiple examples, right? So I have here simple UDB example. So I can run it like this: waf -- run simple UDB example. Okay? I'll printed something nice and colorful. I mean, you could learn how to do that. It's basically what you print to the terminal. Special codes will trigger the coloring. Anyway, Let's look at simple UDB. As you can see here, I have multiple files, and this file here has a main function. What happened if I have a cd, scratch, let me make dir testing something, and let me go to testing something. Now, one thing to testing something, let me touch example code.cc. All the files in NS3 has to have .cc extension. Okay, so now if I go back to my root directory and try just to do WAF, I should get an error. So you see it went back and tried to execute all the programs under Scratch, and then it gave me this error. This is a warning. I want to show you the error by running it again. Yeah, so this is the error message. It says undefined reference to main, because that folder within Scratch has to have at least one .cc file that has a main function. Okay, let me go to Scratch and rm, what is it called, testing something. Yeah, so that we fix it. Okay, moving back, if you want to pass argument, you put the program name and the argument between quotation. And the way to pass argument is the NS3 have a command line interface that is used to handle and parse the argument, which I will show you later on in a bit. If you need to run it in a debuggers, then you use you run this is a program name under your Scratch folder, and then command template gdb --args %s. So I think whatever is here is thrown in here. I think that's how it is done. And if you need to run it with parameter in a debugger, then you basically add the parameters here. So I believe this part here is replaced by the %s, and then it runs in GDB. If you're using LLDB debugger, it's a little bit different. So you'll use LLDB %s like that. Or if you have argument, you do %s -- and then the argument. So in NS3, whenever you write a program, there is something called command line class, right? And basically we could define here command line CMD, and then I'm gonna define argument that I can pass. So I can do --student --age --name, right? So student has a default value of false. X, which is the age, has a default value of 38. And the name has a default value of Adil, that's my name. And then cmd.parse argc argv. You need to do command line cmd as the first lines, only default values precede that. If you run it with PyViz, you need to use command line interface like that. Okay, so if you run this, it will tell you, whatever you pass it. So I can pass it --name equals Stephen --age 22 --student, no argument, because this basically flips it from false to true. Notice that I don't have to follow the order, which is why this command line interface is very useful. Also, I do not have to specify them all. I just have to specify one of them. The rest will fall back to the default values. Okay? You can also run it without an argument, and every one of these will have the default argument value. Right. So in NS3, what are the components of an NS3 simulation? So in an NS3 simulation, everything revolves around nodes. Nodes are basically network hosts, right? They don't have to have a networking device, but we can add a list of devices to it. So you can see here, there is a device list, div 0, div 1. Usually we only have 1 or 2 devices in a node. And you can have as many applications as you want, right? So a list of applications. Now, a net device is actually an abstract class in C++ in NS3 called net device. So it's like the parent of all these net devices. And they might implement their MAC and physical layer attributes within the same class, like the simple CSMA network device, net device, which is the Ethernet, or the point-to-point. Or in the case of Wi-Fi, you need different, it's a lot of work to define the MAC and physical layer implementation. With wireless, you have to distance and signal and all of that. So, and also you can have a list of application. The list of application are a subclass of an abstract class in NS3 called NS3 : application, right? And it has access to the node. You can also create your own custom application if you want, extending this class, and you can add application to nodes, and you can start application. So I think we have UDP Echo application, and we have built-in applications that you can use. They're all a subclass of application. There's also a channel. So basically, when you have a net device, two net devices are connected to each other. And what governs that connection, basically the delay, the propagation delay, stuff like that, is in each corresponding channel object. For example, in a CSMA net device, which is of the Ethernet, there is something called CSMA channel. And for Wi-Fi phi, which is physical, there is something called YANS Wi-Fi channel. YANS is yet another network simulator. And as you can see, there is, for the wave net device or Wi-Fi net device, there is a regular Wi-Fi, and the Wi-Fi MAC is defined in a separate class, and the physical layer is defined in a separate class, just because it's a lot of code. So here's an example. Nodes. If you want to create nodes, you could simply just do node container nodes, and then nodes that create, and you create 10 nodes inside a container of nodes. All right? And you can iterate through them like that. You can get a pointer to each node, just like this. Get at I. And if you want to get the number of nodes in a container, get n. All right? So you can also iterate through a list of net devices and a list of application within a node. We'll see that later. So I think I explained that net device is an abstract class, and you have examples like point-to-point net device, CSMA net device, or Wi-Fi net device. You can also have a net device container, which contains multiple net devices. All right? And I talked about this when I described the diagram. Just for completion, I just have it here. You can iterate through the devices of a network, of a node, by first get a pointer to a node somehow, so maybe from a node container, and then get n device. This is the number of nodes in a device, and number of devices in a node, and then get the device at I, and then do the type checking if it's and then you do the casting if you want to perform the casting and whatnot. Because this is a general net device, is an abstract class. If you understand polymorphism in C++ or in programming, that's how it's done. Okay. Channels, I talked about channels. You don't usually deal with channels, but basically it's what governs the propagation, delay, and loss in case of wireless or in case of, wired. Packets, that's how we exchange data in the internet, although we have frame and segment, but in NS3 we just say packet, right? We remove and add headers. They're added as the packet goes around the simulation. They can contain headers like IP version 4 header, or an ARP header, or an Ethernet header. So an Ethernet header is basically a packet within the link on a CSMA net device. So it's like a Ethernet connection. ARP is the address resolution protocol, or an IP header. So usually that's buried deep. And then there is a TCP header or a UDP header, and so on. Okay. And also you can attach headers to a packet, but I actually recommend doing it with tags, and I'll describe that later. So to create a packet, an empty packet is like this. This is a packet with 0 payload. This is a packet with 100 bytes of payload, and that's basically of all zeros, okay? You can also specify a payload by saying it's this string, convert it to a byte array, and then use the byte array and the length of that array. Okay. Can enable printing, because if you want to print packets using the toString function, then you do that. It will print details about what's in the packet, like all the headers and stuff. We can also examine packets with peek header, remove header, by doing something like this, although this is not safe because, as you can see here, this actually works. I should have Ethernet here, and it will actually work but give you the wrong results. So basically, if you're sure that the first header is an Ethernet header, you can do that. Okay, we're back again. So yeah, this peek header, basically only if you're sure that the first header is Ethernet header, in this case, that you should do peek header. And you cannot remove header if the packet is const. Some callbacks have const, so you cannot remove it in this case, so you may need to copy it. So this is an example where there are no headers here, but this one passed because I think there is enough space in the packet to fill in with this header. Anyway, I think 14 bytes. Packet tags is how you should exchange information between over packets. And so a packet tag does not actually change the object of the packet tag, the packet itself. And that allows you to add packet tag to those packets that are const. Const means like you shouldn't change it once it's created. That's what the const mean. And so you would create a class as a subclass of tag, NS3 tag, and then maybe have an accessor and mutator functions like set value or set X, set Y, set Z. And I will talk about how to create your own packet tags later. But let's say you have a my data tag is a packet tag that you created. And then you could just set a value to 22.5. And then using the packet object, you could add a packet tag, which is this T. If you want to extract it somewhere at a receiving end, then you create a packet tag, empty object, and then use peek packet tag, and then basically this passes it by reference. T here, the value will change, and then you could extract the value you put there. Okay. Now with packet tags, you can only add one packet tag of a certain type. So if my data tag is added to a packet, you cannot add another tag of a class named my data tag. So just to keep that in mind. Okay. Also, another component of NS3 is the applications, and you can create your own application. In NS3 have something called application container, which contains a list of applications. Okay. So applications are typically, there must be a subclass of the NS3 application class, just to know about that, because you will use applications that are, just to know that they are subclass of application, and just in case you need to look at the documentation, you need to look at inherited functions and so on. And a list can be in an application container. Now, mobility is where nodes have a mobility object attached to them so that they can move around. Mobility is necessary if you have wireless communication, because that's how the signal is computed over distance. So that's how basically you calculate whether it's lost, whether it's, what's the signal strength received. And that's why you need mobility to determine the location. We got different kind of mobility, different kinds, like constant position mobility model for a stationary node, constant velocity, random waypoint. And there are many others. You can look at the subclasses of mobility model in NS3, and you could see the kind of mobility mobility subclasses. I can talk more about mobility, but for this sake, we don't really need mobility just yet. So, and we're not going to talk about wireless, so we'll talk about wired networking, and so you do not need mobility modeling. In NS3, actually, if you're familiar with software engineering, the concept of object factory, there's something similar to that is used by helpers. So there is something called helpers. For pretty much everything in NS3, there is a helper that helps you install or set up a network or whatever. And we'll come across these all the time. They use a concept called object factory. Basically, you construct an object and you determine the attributes and the setup before you even actually construct the object, and then you construct objects based on these guidelines. That's the object factory or the object design pattern in software engineering. You can also do it manually without these helpers, but if you want uber control, but you might miss some things as a beginner. And so try to use the helpers as much as possible. Here's an example using the point-to-point helper. Basically, we want to create node 0, node 1. They're connected by a direct connection. It's a point-to-point protocol. And these hosts or nodes will have a point-to-point net device in each of them, and then they communicate directly without anything in between. So here's how it's done. A node container, we create 2 nodes. Then we use the point-to-point helper, okay? We want to set the device attributes. It has this transmission rate or data rate. That's the attribute name. We'll talk about attributes later. And string value 5 Mbps. And then the channel attributes has a delay of 2 milliseconds. You can also use US, which is microseconds. And then you do net device container devices, which is this net device container, point to point, which is this object here, that install nodes. The point to point that install must take a container that has exactly 2 nodes, or you could pass 2 node pointers so that you create the link. And basically that creates the link. So this is part of the code that does that. There's nothing, there's no data, there's no nothing, just 2 nodes and a connection between them. Now, we will want to set up the internet stack, basically IPing and all of that good stuff. So basically it's as simple as doing internet stack helper stack that install nodes. So this is the node container. Then we want to set the IP addresses. So we give it a base 10.1.1.0, and this is a subnet mask. And then we will use IPv4 interface container to basically gather up the interfaces together. And then we use address, this object right here, that assign the IPs to the devices, okay? And then the devices will have IPs with this pattern. So they will be 10.1.1.1 for the first node and 10.1.1.2 for the second node. So there's nothing flowing yet, so we will need to install application. So as I said, this is an application called UDP Echo Server. And then there is a UDP Echo Server helper, and I'm going to initialize it with port number 9999. And application container, serve apps, and basically I use this helper object that install, and I'm only going to specify the node with ID 1. So we created 2 nodes. The first node has ID 0. The second node has ID 1. Of course, I could pass an entire node container, and it will install it in every node of these containers, of the every node in that container. So also I want to use this application container object, and I'm going to set the starting time to 1 second after simulation starts, and I stop it 10 seconds after simulation starts. And guess what happens next? We need to install the client in node 0. And that's what I do right here. UDP echo client helper, echo client. The target IP is interfaces that get the address of node 1. Okay? Why? Because the server is in node 1, right? And I'm going to set the attributes of this client, UDP echo client, max packet. Only want to send one packet, max. So only send one packet. And I'm going to specify an interval as a time value of 100 microseconds. And I'm going to specify attributes packet size as an unsigned integer of 1024 bytes. And then basically using this helper object dot install, and I want to install it in node.get0. This is here basically means the line continues here. So this is not part of the code. And then set the starting time at 2 seconds and then 10 seconds. And I believe that's the first example in the tutorial. They use this exact same code, almost exact same code. I think I might have changed the port number. Okay, and basically we can run this and see how it goes. I think this example, let me vim source, what is it called? Examples. Was it examples? No, vim examples tutorial first CC. So I added some code here. But basically, we have it right here. I'm setting the device attribute and the channel attributes. And then here I have the echo server install. It has the port 9. I just used 99999. And then basically the, yeah. So if you run it, I think I ran it and it generated those PCAP files, or generated output or something like that. What was the number of packet? Max packet, yeah, 1. Okay, so it's only 1. So 1 packet goes, and then run first. At time 2, client send this. At time this, client send, I think client sent 124 bytes to port 9. Client send, I think I might have changed it a little bit. Server received, and then server sends an echo back, and so on. And then the client receives it. Yeah, I think I have multiple prints somewhere. I'm not sure. Anyway, let's go back to this one. All right, a more complex example involves routers and Ethernet. So I have an Ethernet network here. The Ethernet is implemented with CSMA, Carrier Sense Multiple Access. And then there is a CSMA channel, so we give it an attributes like delay going within the channel. And we have router nodes. I have 3 router nodes. As you can see, this router node is part of this LAN. So this router node has a CSMA NAT device and a point-to-point NAT device to this guy here. And this guy here has a point-to-point NAT device going this way, point-to-point device getting that way. And this router here has a point-to-point here and CSMA here to the other LAN. So this is an example. To build this, I have the example right here on my GitHub. Let me open it up. And you can actually see the code and get it for yourself. So I'm not going to go into the details of the code, but basically, I create a node container LAN 1, node container LAN 2, and then router nodes. And then I create N1 is how many nodes I want in the first LAN, how many nodes do I have in this want in the second LAN, and then router nodes, I want 3 routers. And then I want to add the first router to LAN 1 because it is part of LAN 1. Then we use CSMA helper by setting the data rate to 100 Mbps, setting the delay to this many nanoseconds. I don't know, that was in the examples. And then define a net device container and then install in LAN 1 nodes CSMA net devices gets installed. The same thing with LAN 2. I'm going to add router at with ID 1. So the second router, I'll add it. So I think the third one is in the middle. So it's router 1 to router 2, router 2 to router 3. So I will do the same thing and then install, and I give them that connection. Now I'm going to use point-to-point net device helper. I'm going to give it a data rate of 10 megabit per second and a delay of 2 milliseconds. I'm going to create a net device container first hub links. And in this case, I'm going to install point-to-point net device between router node at 0 and router node at 2. So router node at 2 is in the middle. And then I'm going to do net device container second hub links. I'm going to install another point-to-point net device into router at position 2. So I have 3, 0, 1, 2 in the router nodes between 2 and 1. Okay, so this one too is basically this person right here, this node right here in the right side of the slide, because it has point-to-point net device here and a point-to-point net device there. All right. And basically the rest is setting up IP addresses. So for LAN 1, I'm going to give it this prefix. For LAN 2, I'm going to give it this prefix with 2 here. Between the routers, I'm going to give it that 100 between the first 2 routers, and between the second 2 routers, I'm going to give it 200 prefix. And that gives them IP addresses. And then I can just do the UDP echo just like I did it earlier. So I'm going to install the server in all the nodes of LAN 2, and then an echo client that targets basically the address of the device, the IP address of the node 0 within LAN 2 interface. If you look here, LAN 2 interface, I assign IPs to these devices. It's a little complicated, but you could follow through it. And client nodes, I can also install. Let me just create a new net device node container. And let's say LAN 1 nodes get 0, LAN 1 nodes get 1. Then I can install in this. Actually, I did not use this part. So I did not use this this part here. And I can install it in the client node. So I install it in node 0 and node 1 within LAN 1 nodes, and then set the starting time. We also need to do IP version 4 global routing helper populate routing tables, because packets are routed. You need to populate the tables within the routers, how to route the packets. Remember, it's possible to have more point-to-point net devices going to different networks and so on. And basically, you're ready to go. You can enable PCAP, packet capture, and you will generate PCAP files that you can examine with TCP dump, or maybe with Wireshark. All right, so this is by the example. I'm going to talk about a concept called the smart pointer. So if you ever use Boost, C++ Boost, this is similar to it. So basically, pointer are represented with PTR and then the class name within, and you could create a object of node, because node is a subclass of a NS3 object class. So that's how you do it. Packets are not a subclass of object. Now, don't ask me why they did it that way, but basically that's their design decision. They must have made it a long time ago, and it stuck. So with a packet, I just create, and this is the constructor that takes only one integer within the class packet. Okay, 200 payload of all zeros. When you do typecast, so let's say we have a node pointer, and then I want to get the device at 0, and I could do a dynamic cast of this type to this Wi-Fi net device. You can also check the type, and I believe I have it somewhere here. when I talked about iterating. So you could check if the instance type ID of the device is this type ID, then you can safely perform the casting. Let me go back here. Okay. You can copy using copy object. So I can copy a node to another node, just in case you want to use that functionality for whatever reason. And because packet is not a subclass of NS3 : object, you copy a packet by just using the function copy, packet pointer to packet copy. Then you can get a copy of that packet. So in simulation, you want to simulate an event. This is a complete code. I'm going to include NS3 core module, and I'm going to call this schedule. It's not I here. It should be some time. So let's say at time 1, after simulation starts, call my function. So this gets called, prints the time. And then I can also call a function with parameters by doing AND parameter function, and then the parameters, first parameter, second parameter gets passed like that, and then should print the result. Simulation stops at 20 seconds. And that's how you schedule an event, because you might want to do that for whatever reason. If the function is in a separate class, let's say you have a class, my class, right? And it has my class fun1 and my class fun2 with parameter. You create an object of that class, my class, and then you do simulator schedule, and then you use the class name : function name with an and here, and then comma object. So you're calling this function on that object. Or if you need to pass an argument or more, you can list them after that. So fun2, object, and then the parameter. Don't do function overloading. So don't have multiple functions having the same name but different signature, because it confuses this NS3 functionality. So basically create a function with a different name to do that. So there's some sort of implementation of reflection, but it's not really like a reflection. It's basically the attributes and trace. So basically, in a class, C++ class in NS3, it has attributes and trace sources. And so these are all defined in a function called getTypeID. And getInstanceTypeID is used to get the runtime of the object. If you know your polymorphism, you know that you can use a general class and then you can downcast it to the subclass if you're sure it's an instance of that class. Otherwise, the cast fails and you get an error. So the attributes, we have seen them here when I do the UDP Echo client. This is an attribute in UDP Echo client. So I have here NS3. And let me go to the documentation. And I'm going to go to the documentation. And I think it is Doxygen. I want to look at the Doxygen. Let me increase that. So I'm going to go to the class UDP. So I'm going to click here, all attributes, UDP, ouch. UDP Echo client, as you can see, it has max packets, interval, remote address, remote port, and packet size. And if I examine here, and I go here more, you can see here the type of each attribute, so a time value or an integer value or an address value, and so on. So I have here max packet, interval. So they are attributes, and they use an object factory to set everything up there. Yeah, of course, you can use the normal programmatic way. So if I iterate through an applications of a node, this getIn application gets the number of applications installed in a node. And then maybe I want to check if it's an instance of UDP Echo client, downcast it, and then call the function set data size instead of using this packet size right that. But also, the attributes, the reason why they have attributes is they have this way where you have a string path to all the applications or everything in the simulation. For example, if you want to change the packet size to 512 in all the applications in NS3 that are UDP Echo Client, it goes and iterates through all the nodes. So star matches all the node IDs. And then within every node, there is an application list, because in the node class, there is an application list attribute, right? And then star, because you have 0, 1, 2, 3, 4, 5, whatever number of applications you have there. And then here confirm that it is a subclass of UDP Echo Client. And then within UDP Echo Client, this here is an attribute of UDP Echo Client, and then set it to uinteger value. Let me look at the node class just to show you what I mean. If I go here to all attributes and NS3 node, as you can see, I have a device list and an application list. And this is why I have an application list here. Also, if I go here and examine, as you can see, application list is an object pointer container value, which is why here there's a star which matches 0, 1, 2, whatever number of applications we have there. And yeah, basically set it to this value. This string is called the path to an attribute. And, you know, it gets tricky, but you get used to it with usage, right? There's another example. If you want to set the channel property, there is a global list of channel in NS3, star all the channels that are of this subclass and the delay attribute, and I want to use set, and basically time value is second 3. I want to change the delay to 3 seconds, which is very long, but yeah, you could do that. Another way we can actually use an object pointer. So let's say I have UDP Echo Client dynamic cast, and then I can use get attribute. So this is passed by value, and then I can get the packet size like that. So I did not need the whole path because packet size is an attribute of UDP Echo Client. This is just the docs again. You can see that UDP Echo Client have these attributes and so on. And this is how they're defined in the get type ID. You don't need to understand this, but just in case you want to look at the code, this is how it looks like and how it's defined. Trace sources are very important. So these are events that get triggered over time. So that you access them just like you access attributes, but you need to specify a callback function that has a specific signature. So here we do config connect all the nodes, all the application, UDP Echo Client, trace source is TX, which requires a signature that have packet with const here, and a context, basically this whatever matches, whatever string matches here. So if it matches 0 or 1 or 2, that's the value of the context. So because this matches multiple, can potentially match multiple nodes. And if I look here at trace sources, UDP Echo Client, as you can see, we have TX, RX. If I click here and click more, I can scroll a little bit. You can see here the signature required for TX is pointer const packet. Okay. There is another one which is TX with address and RX with address. Let's say here, which actually requires a signature that have const packet, and then const address. By reference, you have to match it exactly or it will fail. Okay. So this is another example. If I have the pointer to the UDP client, then I could basically use client. use without using the path, just like the attribute and the signature of the callback function. Notice here that we do not have the std context string like in the previous example, because we are connecting without context. We know that we have this particular pointer. And for this case, whatever matches, like if we print the context string, if I get this string, it means it's the third node, the application, the zeroth application, like the first application. And basically, this is how attributes are created. You could look at the code, as you can see here, mmactx trace. This is in point-to-point net device. As you can see here, the signature here defines how if you look at the header file, you could see that it has this signature, ptr const packet. So you match. This is another way if you want to look at the code. And this is how you connect if it was without context. And this is how you connect with a context. I'm going to continue the video in a bit. Okay. So, yeah, I can actually look at the code in point-to-point net device, and I can see that the signature here matches. So if you need to look at it from that. So you have different ways to look at it. For example, let me go back to my UDP Echo client, and I can look at get type ID. Get type ID. If I look here at TX, as you can see, the signature is ptr const packet. And with two addresses, it's ptr const packet, const address. So if you need to know the signature, I will help you with these if you need help, if you ask me a question, if you need to inspect certain things. Okay. This is another example if we want to use Rx with address, which is in the UDP Echo client. This is the signature required. So this is the callback we created. If we connect using the object without context, this is the signature. Or if we connect with a path, then the context here will be the path. And this is the signature matches what I was looking at earlier. Okay. Here is another example. I'm going to connect to node list star, device list star. So all the nodes, all the devices, but the devices that matches point-to-point net device. And I want the event mactx and the make callback to and mactx trace. And this fires whenever this device sends something, right? You can look at the simulation here. The documentation here, trace sources. So point-to-point net device, there is mactx drop. There's a lot of them. And I can look at the details and mactx. You can see the signature is ptr const packet. And that's why we have ptr const packet. And the first argument should be the context in case we're connecting with context like that. If you need if we can use this if we have a pointer to that device, but I don't want to do that. There are also ways to get attributes and set attributes with failsafe. So basically, you return false if the matching doesn't work. So let me go back here. Set here, I can use set failsafe, which tries to set the value, but if it fails, it will return false. Okay, so this is one way you could, if you want more checking during compile time, and it returns a Boolean. If you're using NS 3.31, the latest version, you can also use connect failsafe, which will return false if the connection fails. So here, connect. Instead, you can have connect failsafe. Okay. Logging. So if you are programming, writing programs, you notice yourself having print statements here and there. And then when you want to submit the program, or if you want to run it without these prints, you have to comment them out. So NNS3 is a way to have multiple level of log statements that you can turn on and off with basically little code or passing arguments. The log levels, if you notice the example, the first tutorial example, you can notice that we enable UDP Echo application, log level info, UDP Echo server log level info. We can remove that and then not have any log messages printed out from these applications. You know, at time 2 seconds, client send this, and at time whatever, it received that. So this is called a log level info. You can change that to log level all to basically log everything, even function calls and everything. There are different levels: info, warn, error. Error, warn, debug, info, function, logic, all. All means all log messages. And then logic is from logic all the way to error. Function logs function and above. Info logs info and above. Debug log debug and above, and so on. I have examples of these in my code. And you can also see it around in NS3. You can also enable logging from command line. So before you run the WAF like that, you can pass ns_log equal UDP Echo client application, and then you run the example. You can also enable what level, and you can enable multiple ones if you use quotation, and then column between each component. And here with UDP Echo client application, I'm logging everything. And with UDP Echo server application, I'm logging level info. And then basically the rest is WAF, whatever. Okay? By default, if you don't specify a level, it's all. Here's an example of little code. So if you have any piece of code, you can use ns_log_component_define, give it some name. I'm calling it my beautiful program. And basically in the main function, I have log component enable, my beautiful program, log level warn. So what will be printed here? It will be warning and higher. So it should print, this is a warning message. This is an error message. It will not print the info message. And this is ns_log uncond, which will be printed regardless. And yeah, basically that's what we do. And we can also call a function and have ns_log function, which prints out the function name and the parameters that were passed. Okay? So I can also call this like this, my beautiful program, and it will only show warning, but not error in this case if you pass it like that. Anyway, that's my bathroom. Anyway, so my beautiful program, all function. So you could basically log level. You can also have prefixes before the log messages. And in this case, the prefix is function. So the function name where the log message happened. You can also have time. And by default, if you don't specify it, it will do node, time, and level. Let me explain that, show that with this example. I'm going to go ns_log UDP Echo client application. And let me just run it like that. As you can see here, this is the time the log message happened. The node ID, if it's unknown, it will be -1. And then the constructor call, set data size. And then now this happens at node 0 at this time. These are the prefixes. And then the function name. As you can see here, it's the time the event, the log message happened, the node ID, if it's possible to obtain it, and then the function, and then the log level, and then the actual message. Okay, so I can actually do this equal info, and it will only print the info. I can do node, I think. No, I got what looks like a Java error. I think it's like this. Yeah, so you can see here node 0 error is where this event happened, and node 0, or you can also do time. So as you can see, for UDP Echo client application, I'm having the time followed by the message, right? And where did this come from? Because the code have UDP Echo server application enabled. That's why these messages are printed as they are. Okay? All right. So you can play with this and see what happens with you, right? You can also, just to appreciate how much work is done by NS3, you can do nslog star, so you can enable logging on all component, and you can enable log level info, and you can see that you will have a lot of things. There's a lot of things happening in NS3. Star equal info. So there's a lot of work happening. Let me just do a function so that you see, or is it func? Yeah, it's func, sorry. And this is all the function call. It's supposed to do more than that. Let me just do star. Let me just do star. See all log functions. There's a lot of log functions. There's a lot of things happening when simulations are created. Let me just stop this because this will take forever. All right, back to this. Anyway, visualization. So if you can generate, there are two types of visualization in NS3. There is the NetAnim visualization. So I have here, let me open a new directory, change the font, NetAnim. If you build it, I think it's like this. Did I ever build it? I don't think I built it. All right, anyway, I have a shortcut for it. So NetAnim, if you have it, it will be this application where you open an XML trace and see the simulation, visualize it offline. So in order to do this, you just have to do packet enable metadata and animation interface anim and a file name to store it. That's it. It will generate offline trace that you can visualize later. You can also use PyVis, which is a visualization, live visualization of the program. And the way to do this, let me go back to this one. WAF dash I'm too lazy. Viz. And it will create this visualization. Will show packet at time 2. That's it, one packet. Back and forth, it was too quick. Okay. So this is a live simulation if you use PyVis. And for PyVis, you need to make sure that you got the prerequisite for it. This is how you run a program with PyVis. It requires command line cmd, cmd.parse argc argv to be done at the beginning of the main function, so that, because this is an argument that gets passed and has to be parsed. If you need to do PyVis with what you call this, a command line argument, then this is some program, and then you pass the argument between quotation, the program name and the argument, and then pass dash viz. Here's an example with UDP socket, just basically creating the socket ourselves. So I'm going to do type ID TID equal type ID look by name UDP socket factory, and I'm going to create a socket for node 0. I call it the send socket, and a receive socket in node 1. Then create an IP address bound to any, that's basically the 0.0.0.0, 4 zeros, with a port number, so whatever port number I have. And then I bind the receiving socket to accept that inet socket address. Basically, this IP get any means it will accept communication from any IP address. I'm going to create a destination IP with the interfaces of the address of node 1, and then the send socket, I'm going to have it connect to destination IP port. It's not the connect as in connection, but because UDP is connectionless, but basically this is the function that we use. And then I can have a receive callback. So for the receive function, set receive callback, make callback, receive handler, and this function here will have the socket. Whenever a socket packet is received on that socket, I'm going to print the output. And then this is the rest of it. I can create a packet and then call the send packet function using the socket object and the packet object. As you can see, this is like socket object and a packet object. And then I'm going to send the packet on the socket and then schedule another send in 1 second. So it will keep sending packets every second if you want. For fun, I'm also going to connect to MacRX for point-to-point net device and then just print that information. You can also create an application, your own application, and put these sockets in them. Although that's a little bit more advanced, but I have the example here, just a skeleton, and I have the code in my GitHub repository. You can access that if you want to. So in this example, we create the UDP applications, or sorry, the UDP simple UDP applications, which is similar to the UDP echo, but this time I'm not using a helper. I'm using my own object and just creating it as it is like that. Set a start time, and then maybe get the add the applications to the nodes. And then here's a destination IP, create a packet, and then call this function, schedule a call to this function using the object to that application, the packet, the destination, and the port. Because this here send takes packet, destination address, and the port number. The code can be found here if you need it. I have simple UDP application, UDP socket application. Anyway, so yeah. The last thing here is packet tags. I do not expect you to create packet tag like if you're a beginner, but you need to create a class as a subclass of a packet tag. And you need to, basically in this example, I have node ID, timestamp, and a position. And so I create instance variables. And I have accessors and mutators, and then subclasses of, inherited functions from the tag have to be implemented. So the inherited functions serialize and deserialize has to be done in the same order. The same order we follow here is the same order we follow here. So basically, serialize the timestamp, serialize the X and Y and Z of the position, and then serialize the node ID. So we use write double, write U3, and then the reverse is done for deserialize. I actually have an example on this in my GitHub as well. I should visit that right here. So you can go to examples. I think I have Vit custom application. So I think I have it here. Maybe I should put it in a separate class. So I have a class here that has the definitions, and then I have the .cc, which basically I do the serialize and deserialize functions. Anyway, I think that's I've covered enough about the NS3 introduction. If you have any questions, email me at my email. And good luck. If you're one of our Clemson students, you could reach out to me on my Clemson email. You can ask the professor about my email. I'll post it here. And if you're a visitor from the interwebs, hi, subscribe to my channel. And thank you very much for watching. This has been long video, and I'm tired. So thank you and have a nice day. Subscribe to my channel and like it and share it with people who might be interested. Bye-bye.